So I'd been doing a lot of chatting on websites about climate and CO2 and all of the scientific aspects of it. And I couldn't believe that nobody knew why ice ages occurred. And I was having an argument with a very eminent astronomer, and he said, well, the establishment view in that it's all controlled by orbital motions has to be correct. Even if there are large pieces of the puzzle missing, it has to be correct. And I thought, well, that's not a very scientific viewpoint. If you've got large elements of the theory missing, there's something wrong with it.
But it's very similar to how people think about global warming today. It has to be CO2, they say.
Yes, because they're only looking at one of the options. And therefore, if you only look at one option, that's what you're going to find. But correlation is not causation, as they always say in science. And so it was very inadequate, their descriptions, because, excuse me, the actual opposite occurs. So during the ice ages, when CO2 is at a maximum, the world cools. And when CO2 is at a minimum, the world warms. Now, it would not be doing that if CO2 was the primary feedback agent of temperature on the Earth. And so that's a conundrum, that was not explained in the scientific papers. And I read a lot of scientific papers because when I started delving into this, because I came up with my little theory, and this scientist came along and he said, well, if you want, we can make this into a proper scientific paper, but you've got to read these papers first to give the general picture of, what's known in this field. So he slapped down about 75 scientific papers and said, right, okay, read through those.
A weekend work, right?
And then we can, and then we can start somewhere. So I did. I sort of read through all of these papers. And nowhere in any of these papers did it sort out the problem which we were looking at, which is CO2 high causes cooling. Low CO2 causes warming. Totally the opposite of what they're saying today in the climate argument. And that's a very basic problem because it not only affects the ice ages, of course, it affects what we're doing currently with climate research. It's part and parcel of the same argument. Whatever you find for the ice ages affects us now. And so this had a great bearing on what was possible for current climate research. So I felt it was quite important, and it was important that we understood the truth, or at least another theory, even if it wasn't the truth. It's another argument to take into account when you're looking at climate research. CO2 is not involved in this story at all. There is no CO2 element in this story whatsoever. Remember, CO2 lags the warming. So you get warming first, and then you get CO2. If CO2 was the feedback agent, it should be leading the warming, but it doesn't. It actually follows the warming. And the reason that the CO2 follows the warming is because warmer seas exhale CO2. So as you get an interglacial and the seas warm, CO2 will naturally increase because it's being exhaled from the oceans. And so it's consequential. It's not causal. It's following the warming. And so CO2 is not involved in this story whatsoever. You could take it out of the argument completely. It's just non-existent. The reason why we get these great summers every roughly 80 or 100,000 years is because of the eccentricity of the Earth. And that causes a cycle upon a cycle within the Milankovitch cycle, so that some great summers are extra strong and some are weak. And that follows about a 100,000 year cycle. And so if you've got a weak great summer, even if you had some dust on the ice sheets, it's not necessarily going to cause warming because it's a weak great summer. What you need is a really strong great summer, and that's going to produce your warming. And that only occurs every roughly 100,000 years. And that's why we see this 100,000 year pattern within the warming cycle. So what you need for warming is dust on the ice sheets, a nice thick layer, 10,000 years perhaps of dust on the ice sheets, and a very strong great summer. Then you will get warming, then you will get an interglacial. But what we haven't explained, and what you asked for before, is why do we get dust? And that's a real conundrum. Why should dust only appear every 100,000 years? How can dust be tied to the orbital cycles? I mean, it just doesn't make sense. Why would you get dust? And that took a long time, and we were stalled on the paper at that point because the paper didn't explain everything. So we sat there for several months mulling over this. And finally I realized that warming is caused by CO2, but not by CO2 getting too high, but because CO2 was getting too low. So it's low CO2 that causes warming. Again, total reverse of what they're seeing today. Why should it do so? Well, because there is an unspoken truth, which nobody will mention in the modern world, in that CO2 is the most important gas in the atmosphere. CO2 is plant food. Without CO2, all life on Earth dies. And what they won't tell you is we were very near to the extinction event. Even in the modern world, we were quite close to the extinction event where all life on Earth dies. We were hovering around the sort of 240 parts per million mark in the pre-industrial age. If you get down to 150 parts per million, all the plants die. And if all the plants dies, all of the animals die. The only thing left on Earth will be mushrooms. And they'll have a few million years to chew up the old vegetation matter before they die as well. Without CO2, all life on Earth dies. But of course, it doesn't all die at once because CO2, the partial pressure of CO2, decreases with altitude. And so you will get death at higher altitude before you get death at lower altitude. And just looking at it, if you go up to the tree line, the critical figure is about 190 parts per million, where, plants can still survive roughly down at sea level, but at high altitude, all the plants start to die because of a lack of CO2, because the partial pressure of CO2 of all gases will be lower at that altitude. And that explains why we get sudden amounts of dust. So CO2 goes down during the Ice Age. So the CO2 levels within the atmosphere follow the temperature precisely. And that's why people have said, CO2 is controlling temperature because they follow each other exactly. But remember, correlation is not causation. In the modern world, the rate of climb of CO2 seems to be proportional to temperature, both rising at the same time. But the rise in milk production in the world also is correlated to temperature. But that doesn't mean that milk causes temperature rises. Correlation is not causation. You've got to have a way in which the one can affect the other. And so, okay, we have CO2 following temperature during the Ice Age. As the temperature drops, so does CO2 drop. As temperature rises, CO2 rises. And you can say, well, there's a correlation. Yeah, but there's not causation. Because what they won't tell you is that dust also follows temperature, and it follows CO2. So if you do a graph of CO2 versus dust, they correlate precisely, but inversely and logarithmically. So you've got to plot the dust logarithmically against CO2, and it's a perfect match. But because it's logarithmic, if you get a small drop in CO2, it makes a huge rise in dust. So why is CO2 controlling dust? There's a correlation, but is it causation? What's the mechanism by which CO2 causes dust? And the answer is that CO2 is plant food. If there is a lack of CO2, the plants die, the earth is now exposed, and the wind can now take that earth, that dust, and push it across the lowest plateau in China. This happens at high altitude first, not at low altitude. So what we're looking for is high altitude plateaus that can be starved of CO2, and therefore turn into CO2 deserts. And so we have this wonderful term, which takes a while for people to get their head around this one, because we're so used to aridity deserts. If you have a desert, it's because of a lack of water. No, during the Ice Age, deserts were caused by a lack of CO2. And so at high altitude, you would have these vast CO2 deserts forming. And the classic CO2 desert was the Gobi Plateau. The Gobi at present, you might think of it as a desert, but very little of it is actual desert. It's steppe grassland. It's covered with grazing animals all over it. During the Ice Age, as the world cooled and as CO2 fell in unison with the temperature, because the seas are absorbing the CO2, that's why the CO2 goes down. So the colder the seas are, the more CO2 they can absorb. So CO2 goes down with temperature. It reaches a point on the Gobi Plateau where all of the plants die, and you get a CO2 desert. And now this CO2 desert is exposed its virgin soils to the wind, and the wind can now take that material and dump it all over the lowest plateau, and dump it all over the Greenland ice sheets, and all over the Laurentide ice sheets, and all of the other ice sheets around the northern hemisphere. And that is why we get dust. And climate scientists are so obsessed with CO2 and temperature that they don't understand this whatsoever. Two instances. My paper was peer-reviewed, of course. And the review came back. This was from the Royal Society. You've got to wonder about these people sometimes. The Royal Society in London. And the peer reviewer said, well, this paper is wrong completely, because there is the same percentage of CO2 at high altitude as there is at sea level. You know, there's let's call it 200 parts per million at sea level. There is 200 parts per million CO2 on the top of Everest. It's the same percentage. Yeah, okay, fine, thanks very much, but there is less of it.
Right.
There is the same amount of oxygen at sea level as there is on the top of Mount Everest. Proportionately, the same percentage, call it 22%, whatever it is. There's 22% at sea level, there's 22% of the atmosphere on the top of Everest is oxygen. But you try climbing up the top of Everest and see what happens to you. The partial pressure actually lowers. There is less of it, and so you can't breathe, and you die on the top of Everest.
We had a famous
That's why
death
we have
fairly
oxygen
recently.
generators on aircraft. Yeah, that's why we have oxygen generators on aircraft. You know, the proportion of oxygen in the atmosphere at 35,000 foot where you're flying in your commercial airliner, the proportion of oxygen in the atmosphere is exactly the same there as on the surface. But if you lose pressurization in the aircraft, you're going to die very quickly because there is less of it. And this was the argument that the reviewer was using in order to invalidate my paper, saying that CO2 percentages do not change with altitude. I mean, how dumb can you get, you know? And for that reason, my paper was actually thrown out by them. I had to go to another reviewer. I had to go to another body to get it passed. And I went to Geoscience Frontiers, and they passed it. And the other one, which is almost as bad, no, actually it's probably worse, was this wonderful paper I saw on paleoclimate. They have these paleoclimate maps, which are very nice, very detailed, of the whole Earth going back through the ages, showing what the temperature and the precipitation and various other aspects of the climate were all around the globe, going back thousands and hundreds of thousands of years. And they're very nice, very useful, not terribly accurate. Because this paper on South American tree lines, how do you determine the temperature? Well, there are various ways of studying fossils, minute marine fossils, which will tell you the temperature of the seas at sea level. And they've used that to determine the temperature of the Earth going back through hundreds of thousands of years. How do you determine what the aridity was, what the amount of precipitation was, the amount of water in the atmosphere? Well, they do that via tree lines. So the idea is, if you look at the tree lines back through thousands of years, you can see the tree line going up and down with temperature. And so if you know the temperature at the surface, and now if you calculate, because certain trees have a certain tree line at, you know, a certain altitude, a certain temperature at which they can live. And that determines where the tree line is up a mountain side. And so you can look for that particular type of tree, how far up the mountain it was with fossilized trees, of course, with remains of fossilized trees. And so you can determine exactly what the temperature was on the top of that hill. And now you have temperature on the surface, temperature on the hill. You can work out the amount of moisture in the atmosphere via the lapse rate. The lapse rate is the reduction in temperature with altitude, which in the modern world, it's 1.5 degrees per 1,000 foot for a moist atmosphere, and it's 3 degrees per 1,000 foot for a dry atmosphere. So you can see the two different lapse rates depending on how moist the atmosphere is. But there's a problem with that. They had to come out with enormous lapse rates because the tree line was much, much lower than they thought. And therefore, it had to be really cold on the top of these hills. And therefore, the atmosphere must have been very dry. And so on the maps, they put all these areas as being very dry, not very humid at all, because the tree line was so low. What they hadn't calculated was the levels of CO2. And it turns out if you do the calculations on how much CO2 was in the atmosphere during the Ice Age, that the tree lines were being modulated by CO2 levels, not by temperature. When CO2 gets down to 190 parts per million at surface conditions, it is CO2 that becomes limiting in the tree lines going up a mountainside, not temperature. So they were calculating the wrong causal element because they didn't understand that CO2 kills trees. And, you know, trees need warmth, but they need CO2 as well. Otherwise, they can't
So the
live.
lack of CO2 kills trees.
Yeah, absolutely. And therefore, the lapse rate they calculated was totally incorrect because they were determining it on temperature. It wasn't on temperature. It was determined by CO2. And so the temperature could have been much warmer on those hillsides than they had calculated. And therefore, the lapse rate might have been a normal lapse rate that we get today, an average of 2 degrees per 1,000 foot. And therefore, all of their paleoclimate precipitation maps were actually wrong, because they think it was much more arid than it actually probably was.
During the last ice age, how low did carbon dioxide get in the atmosphere?
About 190 parts per million.
And how was it before the industrial age in recent times, like during the Little Ice Age?
240.
So we're very close here.
Oh, yeah. It doesn't take much to go down. Doesn't take very much. I mean, we were in the pre-industrial age, we were hovering around the death point for most plant life. 50 parts per million at altitude, of course. You have to come down to about 150 parts per million at the surface to kill all of the plants on the surface. So you've got to come down 100 parts per million. But at altitude, you will start losing plants at altitude very quickly at 190 parts per million.
So it sounds like our automobiles are saving the planet.
Absolutely. The oil companies and the coal companies are the saviors of the planet, and they should be given a medal for saving the planet and saving the biosphere. They can look at the number of stomata on a fossilized plant leaf, and that will tell you roughly how much CO2 there was in the atmosphere. So, and they correlate CO2 with temperature, of course. So if you have less stomata on your plant leaf, you don't lose as much water. So CO2 preferentially allows plants to live in more and more arid conditions. So the people who gain by having more CO2 are the people who live in arid conditions, up on the Gobi Plateau or on the edges of the Sahara. They benefit the most by having CO2 in the atmosphere.
That's not what Al Gore says.
That's not what Al Gore says, yeah. It's not what most climate scientists will say, because they will not give you the full truth. And if you are cherry picking the data you want to give, if you are cherry picking the truth you want to give, then that is no longer science. That is now political activism. In order for the general public, the intelligent general public, to understand what's going on, you need to give all of the facts, not just half of the facts. And leaving out the established truth that CO2 is good for plant life, that a lack of CO2 is disastrous for plant life, is leaving out not just a small part of the story, it's leaving out half of the global warming story. I mean, you might say, okay, CO2 is causing warming. I don't believe that at all, because my paper has disproved it. But you might say that. But tell us at the same time that CO2 is also promoting plant life. That's still half of the story, even if you believe that CO2 causes warming. I don't believe that CO2 causes warming at all, because of my paper, because within everything we've discussed in that science paper, there is no role for CO2 whatsoever. You don't need it.